Okay, so let's solve the problems in Quiz 6. This is basically a cyclic fatigue problem. It oscillates between a maximum and minimum. So it goes like this. The average stress is just the average of the high and the low, the max and the min. So we add the two together, divided by 2, and we get 150 megapascal. The range of the stress is the distance between the max and the min, and they're both tensile, so this distance is 200. And the amplitude of the stress is the distance halfway of the range, which makes it 100 MPa. The stress ratio, R, is equal to min divided by the max. And in this case, it's 50 divided by 250, 1/5, or 0.2. Note the stress ratio is unitless because it's stress divided by stress, and we wind up with no units. The next problem is a question of creep, and basically this is creep, strain versus time, and here are 3 curves that eventually fracture, and the question is which one corresponds to the specimens that were exposed to the higher temperature. Well, we know that increasing the temperature makes the diffusion go faster, which means that the rate that it creeps and the rate that it creeps is faster, therefore the time to fracture is less. So the one with the least time is here, and that's this one. The next problem is a problem of reading phase diagrams, and X and I equals. So I chose 0.3, and I mentioned that in class. So that is the thick dashed line at 1,400 right here. This is 100% liquid. So I'm going to call this FL for being fraction liquid equals 100%. And the composition, I'm calling this XNIL, the mole fraction of nickel in the liquid, is equal to 0.3. And that's because we know what the total mole fraction is of the entire system, and the entire system is liquid. Next we go to 1,200. So 1,200 is right here. Come across. We're now in a 2-phase region of liquid plus AlNI. So that is going to be our tie line. Dropping down from our tie lines, this gives us the composition of AlNI and the composition of the liquid. So that is going to be around 0.28. And that is around 0.43. So if we talk about the that gives us the composition of the liquid and the composition of the AlNI phase. And then if we want to talk about the phase fraction, we see that it's mostly liquid, right? And we also know from the inverse lever rule that we're taking this distance, so we take FL is equal to 0.43 minus 0.30 over the total distance, which is 0.43 minus 0.28. And that gives us, let's see, that gives us 0.13 divided by 0.15, which is around 87%, which means that the fraction of ALNI is equal to 13%. So write that in. The fraction of liquid is equal to 87%. The fraction of ALNI is equal to 13%. And then we have the composition of the liquid being 0.28 mole fraction nickel, and the composition of the ALNI being 0.43 mole fraction of the nickel. That's from reading where the verticals intercept the x-axis. I'm going to change colors here in order to distinguish them. Next we go to 1000. So 1000, here we have our dashed lines to guide the eye. We're in this two-phase region, which is again is a liquid and a Al3Ni2 phase. We draw our tie line here, drawing the verticals. That is around 0.22. This is around 0.37, which means that for this particular system, or for this particular temperature, we have the fraction liquid being equal to 0.07 divided by the total there, which is 0.15. Fraction of liquid is equal to 47%, which means the fraction of Al3 and I2 is equal to 53%. And we have compositions identified, so we can write our solution in here at 1000. At 1000 we have fraction of liquid is equal to 47%. Fraction of Al3Ni2 is equal to 53%. The nickel composition of the liquid is equal to 0.22 mole fraction, and the nickel composition of the Al3Ni2 is equal to what I call it 0.37. Okay. Lastly, get another marker. Lastly, we can go and look at 800. So 800, we're here. We're in this two-phase region where one of the phases is the line compound Al3Ni, and one is the solid solution Al3Ni2. So Al3Ni, that's 0.25, and you know that because it's a line compound, and as a line compound, we have 3 aluminum for every 1 nickel, so there's 25% nickel. And it's also worth noting as you start counting across here, notice that the ratios here is 3 to 1 aluminum to nickel, here's 3 to 2 aluminum nickel, here's 1 to 1, which corresponds to 0.5, here's 3 to 5, here's 1 to 3, so that's 0.75, and then here's pure nickel. So that's 0.25, and that makes this, well, I'm going to still call that around 0.37. So here I have the 2 compositions now, and in addition to compositions I can get the phase fraction, so I can say the phase fraction of Al3Ni, so on the left, is going to be equal to 0.37 minus 0.30 divided by 0.37 minus 0.25, which then gives us around 58%, which means the phase fraction of Al3Ni2 is equal to 42%. So filling this in, the phase fraction of Al3Ni is equal to 58%. Phase fraction of Al3Ni2 is equal to 42%. Composition, the nickel composition of Al3Ni is going to be here. Al3 of Ni is 25, 0.25, because it's the line compound, and the nickel fraction in Al3Ni2 is going to be equal to, what do I call this? I call this 0.37. 0.37. So that is the solution for quiz number 6.